I am one of Dr. Hodges' students, though, so I took her IBL Calculus 2 course, and then this past year I was a TA for the same course. So I've seen it at the college level. I do hope to teach primarily high school. I don't really want to get quite as big as middle school, but I don't know. So I guess I really haven't seen challenges thus far in secondary, but I don't know.
The challenge we face right now is finding appropriate problems that they can, go forward and make progress. Like I don't want to make it too difficult, but at the same time, I want to make it hard enough that they struggle, and really take ownership of this material. So just finding the right level of problems and doing this without even seeing the students or their capability. So maybe even finding like a small spectrum of difficulty of problems. That way, when I get there, I can judge.
I'm Lance Cantor. I teach middle school, but I teach honors, and they're taking freshman and sophomore level math. And in North Carolina, where I am in Charlotte, it's changed with the Common Core, and now it's Math 1, Math 2. So it goes up to like Algebra 2 and trig and stuff. But I try to use this because this is my third year in these workshops, conferences, and I try to use this stuff as much as I can in the classroom. This year in particular, I do more and more. When I sat down with the parents at open house, it was like a few weeks of school, and all the parents were upset at me because, like you said, like I'm not giving notes. It's not even just the kids will do what I say. They're honors kids. I have control over them. The parents were really upset because they feel like they can't help their kids, and so it was just a learning experience for me to understand that I have to get the parents involved early, let them know this class is not going to be your traditional, here's how you do number 1, 2, and 3, now do 4, 5, 6.
I'm Dan Goldner. I teach at a turnaround school in inner city Boston. So turnaround means the school was failing 3 years ago, and we're in our third year of a process to try and change that. And I think we did it. We won't know until the scores come out in the fall. And I've been teaching something called pre-calculus for the past 3 years using IBL. Every year there's a couple kids that just won't play, that just will not do anything on their own no matter how much extra support I give them, no matter what I try and do. And usually those same kids are also not engaged in their other classes, so it's something bigger than math. This year I had a particularly large group of non-participants, which was a real problem for me, for the other students in the class, for those students, because they were frustrated too, for my administration. So it was a real kind of down year. So my challenge is I don't want to give up on this because of everything Mike Starbird said last night, but I need to have something ready in case that group shows up again next year.
For almost 30 years, I've taught every level from 5th grade to college sophomore, but the majority of my experience, about 20 years, has been in teaching high school. And I specialized in teaching ESL students, and I find that the IBL discovery method is so good for the ESL students. They don't speak English yet, and math is a universal language, and they're more open.
If you are ready to move on, the next phase is to talk about resources. And so something we're going to do slightly differently this year is you've got a large white sheet of paper. Every table needs to select a scribe. And when someone suggests an idea or a resource, please write it down. We're going to stick these to the wall out in the other half of the ballroom. And I'm going to take pictures of them, put them up on Twitter so that if you felt torn about which table you went to, you get to see the ideas from the other tables. So continue communitying.
I think one set of resources for these kinds of things is actually some of the kind of the journals, like the ones from UMAP or from Primus and things like that. They just, not because you do what it says in the article, but it gets you thinking about, well, here's a thing that I could do that's a small thing. Especially, you were kind of talking about trying to do smaller things, and not going to some complete reorganization of a curriculum. I found them helpful, not because I do exactly what it says, but because there's interesting ideas.
Are you all aware of Journal of Inquiry-Based Learning in Mathematics?
Yeah, that's where all the questions
That's
are.
right.
That's less helpful for this for
calculus.
Yeah, right.
Some of us have been involved in that from the beginning, are looking to try to increase what's there to places like statistics and calculus and so forth.
I come to class the next day, well, they just computed a few more function values. And these are kids that have been through AP Calculus. And so then you have to use language precisely. Then we start talking about, what do you mean by X being near? You know, and you introduce absolute values and stuff like that. But the playing field gets level right away, because the people that have had a year of high school calculus, I've yet to see a student do that on the first day.
The professor just comes in and says, what can you say about the function sine of x squared and the function sine squared of x? And that's the question. What can you say about that? So the students go back and they come back the next day, and some of them have some stuff written down, some have the graph, some have this. Many of them have not even thought to think of, well, the domain is this, the range is blah. This one seems to be moving faster. The zeros are this one. There's all these questions that you can talk about. But through all that, you can talk about zeros of a function, what the domain is, what composition of functions are, and that's sort of what I'm trying to go for. Is have this one question where all of these ideas from, in this case, pre-calculus come out, and they actually have a setting for it. Of like, this was the question we were trying to answer. Oh, here's the language that helps answer it. And because it's open-ended, that again does the leveling.
When you sit with a class of 200 students and tell them, turn to your neighbor and discuss your answer, all kinds of things may happen.
Yeah, you can't actually force them to turn to their neighbor and discuss their answer. But yeah, I don't know. It's
Then again, we are teaching at a university level. We're teaching adults, and we're there to motivate and provide opportunities. But we can't, in the end, force our students to learn, and we provide an opportunity, they take advantage of it or they don't. So I don't see my job as to force my students to do anything. I see my job as to create.
And again, I'm not plugging my book, I'm plugging open source. That's
and I put it on this was just one of the things and things you can do with it. And like I said, I like the one by, of course I've used it. Can I remember the name? Jonathan Hodge. So it's the...
Oh yeah, what is the name? I have a colleague who'll be using it in the fall.
Algebra and inquiry-based approach.
Glancing through it, it looked pretty impressive to me. I might very well try that next time I teach.
Yeah, something like x squared. Showing that the limit is
limit of the squares.
Right. Showing that like the limit as x approaches 2 of x squared is 4. Like I formally make them prove that usually in a better calculus class, not one that's not up to that.
I would think that for them to really grasp that concept, the alternating quantifiers there for all that exist, they've just got to do a number of them. They've just got to spend time with it, which you really don't have time to do in calculus.
Well, the way our calculus is set up is that we actually have 6 contact hours a week for the entire semester. So if I devote 2 days, solid class days, that's plenty. I mean, we can definitely spare 2 days out of the semester to do that. So we actually have a decent amount of time.
Exactly, yeah. Or when I talk about the Wronskian, they don't know what linearly dependent means. So I have to spend some time doing that.
Right, I do that.
Yeah.
That's a day right there. Doing linear independence. But it's worthwhile. Yeah. I think so. I have fun with it.
Mine took a linear algebra class, but they don't really understand what linear dependence means. So we do it. We spend a little time on that. But I only do it for 2 functions, so then we're only just talking about, one function is not a multiple of the other. So.
Think of how they are moving. I mean, like from, they're going to geometry, then this fellow is like way up there. They'll be mature by that time, to tackle abstract or real analysis. So that's my experience. Their experience is it goes into abstract algebra. So that's the locality of the problem.
And clearly you want to teach something that helps the next one. Sorry, what did you say, Rod?
You have to teach your own students too. You can't say, I want to teach a class that's going to be great for MIT students. If you're not getting MIT students, that's the local condition.
Number 1, what's... Okay. Yep.
Secondary math teachers or...
Yeah, when I took an Intro to Proofs course at the University of Minnesota, it was 100% math majors, most of whom intended to go to graduate school. The one I'm going to teach this fall, at least 60 or 70% will be pre-service teachers who want to go into a 7 through 12 classroom. And
pre-service teachers, a third math majors, and a third engineering students who are taking a writing intensive class to satisfy a requirement for their pre-engineering curriculum.
So what do you do to address that community? Like, so you have your set of students. How do you approach the class differently than you might?
I mean, that's the endless population I'm always going to have. And so I approach them to try to teach them how to communicate well and how to understand how to read a mathematical statement, make sense of it, and try to make a proof.
Whether we want to put it down and put it on the net and advertise, but Moore taught a very good geometry class that was a very good, precise axioms and proofs. It was based on Veblen's axioms, which are not something...
I was curious which axioms he used.
Not something you're going to do in high school.
That's the other thing that's really challenging, though, about teaching a geometry course, is there's so many sets of axioms to choose from.
Well, and the problem is, if you go to Veblen writes his axioms for mathematicians who start off with 11 axioms, and you overwhelm the students with, you just give them the axioms they need and the theorems, and from time to time you give them another axiom.
What are those axioms called, though? Veblen?
Well, what I'm going to tell you, don't write it down, is that there's a book, and I'll talk about it this afternoon, by R.F. Jolly called Synthetic Geometry. And Bob disclosed to me that in the 70s that it was really his notes from Dr. Moore's geometry class. So there you go. You've got somebody that spent decades developing he didn't develop the axioms, but he developed the theorems at the level for the students, and they have access to it. But for God's sake, don't go up to the blackboard and write the axiom by looking at this book.
No, of course
the students will find it and you'll be dead.
One of the things that I do in my proofs course is strong induction. I always like to cover that. And I have an example that I found, a colleague of mine and I found it. It's a game where you have a stack of boxes, say 10 boxes, and at each turn you're allowed to break the stack into two separate stacks. So you could break it into a 5 and 5 or into a 6 and 4, any way you wish. Then you multiply the heights of the two substacks.
Isn't that wonderful?
Okay.
Yes, beautiful.
And now you take any remaining stack and you divide it and multiply the two substacks of that and add it to your previous score. And what you do is you do this until you have 10 stacks of 1. And of course you can start with any number of stacks. As it turns out, your score is independent of your strategy. There is only one score that you can achieve in this, but of course that's totally counterintuitive to the students. And so what I do is I break them into groups and I have them try to compete with each other within their groups. Each group come up with the best strategy. What they discover is that they're all coming up with the same score, and that leads them to the question, wait, why are we all coming up with the same score? And then they start to pursue what it is about that problem that does that. And so it's a way to get them to make a conjecture. Now, it's a bit sophisticated to get them all the way through the proof on their own, but they end up making the conjecture without me.
It's all in how you phrase the question. So instead of saying, who answered this and why, I'd say, why might somebody respond this way? What do you think the person that responded this thing? And that way you're engaging, trying to get the whole class to think about this. And keep in mind, that one person may be right, and those students don't know that.
Maybe when I'm having groups sharing out in a particular order, and so that I start with a group that doesn't have a full or complete, or maybe even an incorrect answer. And then be able to sort of build that. It's like, okay, like if they got stuck, so how might you proceed further from this, and sort of generate the conversation, and try to do it in a supportive way so that students kind of understand that that's okay, that there's something sharing, and then of course end with a pretty good solution. Because if you start with a perfect solution, nothing's going to happen after that.
Like I said before, I have a problem getting support from my colleagues on this. It's one where everything is computerized. All the homework, quizzes, all that kind of stuff is computerized, very low-level questions, and that is what everybody else wants to do. They don't have a book. We're a university that rents our textbooks, but to even save more money, they're only doing an online textbook through the homework, the Math Excel program. And I've never taught it like that. This upcoming semester is going to be my first semester teaching it with that particular book, with the computerized homework. So my problem is, how am I going to kind of implement IBL in class if this is all they have outside of class is stuff on the computer.
Yes, but mathematical induction proofs are fun when you have to prove two things are equal.
Yeah.
But what about when you have to prove something like you are not really proving two sides are equal, you are actually proving some kind of statement, but still use mathematical induction of that kind of proof. So method of contradiction, method of contraposition, and mathematical induction. Each one you read a proof and you say, okay, what kind of proof is this? Is this direct or is it indirect? And once you decide that, then you read the proof. And once you thought that it is indirect, then you think, okay, is it contrapositive? It is contradiction? Is it mathematical induction? What kind of proof is this?
Then you can have red and black chips, so that you know that if you have a red chip and a black chip, it cancels out to 0.
Oh yeah.
And so then you can take all the stuff that they know for granted. Like, I know that if I take a positive number times a positive number, I get a positive number out. But if I take a positive number times a negative number, why does that become negative? Why is it that I would take 3 plus negative 2? Why am I going backwards down to 1? And if you have that manipulative, then you can hold on to it and say, well, I've got 3 red and 2 black, so I've got 2 pairs with 1 left over that's red, so it's a positive 1. And so it's just a way of visualizing numbers.
IBL is not an improvement if you lockstep it. Might as well use a book. But what you're given the assignments for, this is one version. I'm not trying to tell you what to do, but your problems, the flip is not to go through the book and read what somebody else said. The flip is, before the fact, you're working on the questions that came either consequent to what happened the time before or consequent to the discussion they had and identifying what the first principles were. And then the questions, that's what they bring to the table. And the homework doesn't surface until you see what happens, because you have to, the decision you make every class day on the basis of what I've just now seen, heard, and been a part of. Do I need more on these ideas, or is it time to launch something else?
The discussion that we're having, I have no idea what this has to do with inquiry-based learning, because
it's
I feel like I'm sitting at the table of computerized instruction, which I realize has an important role, because we're teaching a lot of courses where we have to have students develop certain skills, and we have larger and larger classes and more demands on our time, and we have this resource. But I have all of you folks that I've listened to, I've lost the inquiry in what you're doing. I'm sure you're doing it, but I haven't heard anything about it yet.
I think that raises the challenge that we can this crystallizes what the challenge is how do we deal with the proliferation of these kinds of procedurally driven, heavily marketed, online courses, whether it's fully, a completely fully automated thing like Alex, or a homework supplement like My Math Lab or WebAssign. How do we deal with that? And keeping in mind that A, it's easier for the student because it is so procedurally driven, and B, if you're thinking about scaling, it's easier for the instructor too, in some respects.
A little girl who was, I think, 8 years old, and she was supposed to have memorized the early multiplication tables, the smaller ones, and she simply could not do it. She had some kind of a mental block, and I decided, okay, how am I going to give this child a different direction for learning these? And I taught her that if she could add 2 plus 2 plus 2 plus 2 and see how many 2s she was adding together, this way she could learn the 2's multiplication table. And we spent several weeks of the summer with that poor child, getting her little brain into the addition, the switch to multiplication, and the memorizing process. And it worked.
Use it to group work, either 2 tables that can butt together to seat 4 or they're round tables. We have some lecture classrooms that have these long benches with fixed chairs behind them. And we have one classroom that's this way, where the rows go up this way, and I find that easier to work in with groups because I have a lot of ends on the rows, so the students can gather around the ends. We have a classroom that has this configuration where the contiguous tables are longer, and those are more difficult because then people get in the middle, and I can't get to them. Whereas in the configuration, like lecture classroom with this, I can say everybody's going to be on an end, and I can rotate around.
Sadly, we are almost out of time. We've only got about 3 minutes left, so I want to offer a couple of suggestions at the end. Make sure you've shared the ideas and written them down so that other people can get them. Share email addresses with your table mates so that you can continue this conversation. Make sure you took some notes and don't lose them. And that hopefully this was a very helpful situation. So our goals were for you to think about the challenges, think about the resources and techniques, and also build some community. Hopefully that worked for you. And so the last thing is, this is where this information is going to go. I'd like you to take the sticky sheets, and I'll be in the back where Randy is. I'll say something about Randy in 1 second. Give them to me. I'll put them up on the wall. I'm also going to take a picture of each of them and put them up on Twitter, and I'm going to use the hashtag IBLResources, or you can find them in my Twitter account, which is thewordninja_BK. So take your last couple of minutes to share, finish up putting information on your things, on your sheets of paper, and then bring your sheets to me. The last announcement is that if you were going to give Randy your $5 off food coupon for charity, he's right there in bright red. So thank you all. Have a lovely day.